Welcome back to today's session, continuing our discussion of the lesson Matter in our Surroundings. So, the story so far has been everything around us is matter. Matter is made up of particles. Particles are very small, particles have spaces between them, particles have force of attraction between them, and particles possess kinetic energy. And based on these 3 points, we know now that matter can exist as either solid, liquid, or gas. So, this is the story so far. Today, we have to ask ourselves 2 important questions. Question number 1: can we convert one form of matter into another? And if yes, then the next question is, how do we do that? For example, can we change a solid into a liquid into a gas, a solid into a gas? So we will be dealing with what is called as interconversion of matter. Interconversion from one form of matter into another form of matter. So the first question is it possible? Can we convert? Obviously, it is possible. So the answer to our first question is yes. We can convert one form of matter into another form, solid to liquid, liquid to gas, or vice versa. The next question is how? How is it possible to convert one form of matter into another form of matter? In the previous class, we have learned the reason why certain form of matter are present as solid, some other matter are present as liquid and gas. The reason being the nature or the properties of the particles. We know that solids, the spaces are very less, kinetic energy is very less, so particles cannot move here and there. In the extreme form, that is in the gaseous state, particles have high amount of kinetic energy, so they can move wherever they want, and in between we have the liquids. All we have to do is change the property of the particles. If we can somehow achieve increasing the kinetic energy of particles in a solid, we can convert them into liquid. And if you want to convert a liquid into a gas, all we have to do is increase the kinetic energy of the liquid particles. At the same time, if you want to convert, let us say, a gas into a liquid, all you have to do is decrease the kinetic energy, reduce the motion, reduce the movement, automatically they will become liquids. And if you want to convert a liquid into a gas, you have to further reduce the kinetic energy of the particles. Also, another factor here is force of attraction. Once we alter the kinetic energy, the second point, the attraction between the particles will be indirectly taken care of. So we have to look at a way of how to increase or how to reduce the kinetic energy. So how can we do that? How can we increase the kinetic energy? Let me begin with a very simple example. We know that our water can exist in 3 states of matter, in all 3 states of matter. In the solid state, water is present as ice. In the liquid state, it is present as water, of course. And in the gaseous state, water can be seen as vapor. The same compound can exist in 3 different states of matter: ice, water, and vapor, solid, liquid, and gas. So we will take water as an example to explain the phenomenon of interconversion of matter. So water is ice. when we keep it in refrigerator. In a refrigerator, as you know, the temperature is very low. It is anywhere between 20 degrees Celsius to, it can be as low as 0 degrees Celsius or 4 degrees Celsius in our refrigerators normally present at our homes, right? So if you keep a bottle of water in your deep freezer at your home, what will happen after half an hour or so? The liquid would have converted itself into ice. Liquid would have converted into ice. And what is the important factor that is changed over here? It is nothing but temperature, right? So if we can change the temperature, if we can change the temperature, we can convert water into ice. Now, if you want to convert water into vapor, what will you do? If you want to convert water into vapor or water into steam, that is, you have to do the reverse. You keep water on a pan, you on gas or you burn the spirit lamp. After some time, as time progresses, you will see that at one particular point of time, water would start forming steam or vapor. So you would have converted the liquid water into water vapor. So in both the cases, converting water into ice as well as converting water into vapor, what we have done is either decrease the temperature or increase the temperature. So if we can change the temperature, then it is possible for us to convert one form of matter into another form of matter. For example, you have your gold, solid gold. If you want to make ornaments out of it, what does the goldsmith do? He puts it in a furnace, and at a particular temperature the gold will melt and it will become liquid, and then it is very easy to work with gold. So changing in the temperature is one way to convert one form of matter into another form. Other than temperature, there is also one more factor. If we change that, it will be once again helping in conversion of matter. For example, let us say your LPG gas, the example that we used in our previous session. We know that the LPG at our home is nothing but liquefied petroleum gas. In essence, it is a gas which has been converted into a liquid. The gas has been converted into a liquid. How did they achieve that? How did they do that? Because we know in gas particles are moving here and there. So in a LPG cylinder, what essentially they have done is they have compressed the gas, isn't it? They have compressed, they have applied force, they have applied pressure. On application of pressure, particles come closer. So by changing the pressure, also we can convert one form of matter into another form. So we can convert solid to liquid to gas or any other way. What we need to do is we have to change the temperature or we have to change the pressure. So let me begin with change in pressure. It is very easy, and I just gave you the example of your liquefied petroleum gas, right? So not only do we have to decrease the pressure, so for converting a gas into liquid, we have to increase the pressure. We have to increase the pressure so that the particles will start coming closer. We should also do one more thing, that is we should decrease the temperature. We have to decrease the temperature, because no doubt you will apply pressure and particles will start coming closer, but on application of pressure, what will happen? They will start moving here and there more quicker, because their kinetic energy would have increased. Unless we decrease the kinetic energy, particles will not come closer quickly. So on one hand we have to increase the pressure, on the other hand we have to decrease the temperature. On doing both of these simultaneously, increasing the pressure and decreasing the temperature, what we are doing is we are reducing their kinetic energy, and at the same time what we are doing is we are decreasing the spaces between them. So we can convert a gas. One more example, what is called as your dry ice. Dry ice. Dry ice, we use it for transportation of medicine or certain perishable objects, because dry ice is very very cold. What is dry ice? Dry ice is nothing but solid carbon dioxide. It is present as a gas in our atmosphere. So how did they convert this carbon dioxide into solid? By increasing the pressure and by lowering the temperature drastically. So by increasing the pressure and lowering the temperature, they have converted carbon dioxide gas into solid called as dry ice. Once again, so this is about our changing in pressure. If we do this, we can convert a gas into a liquid, or we can convert a gas into a solid. So what is this phenomenon called as? When we convert a gas into a liquid, what do we call it as? What is the term for that? It is what is called as condensation. Conversion of gas into liquid is called condensation. We also saw we can convert carbon dioxide into solid, that is a gas into solid. Conversion of gas to solid directly is what is called as deposition. So these are scientific terminologies that we use for interconversion of matter. Conversion of gas to liquid is called condensation. Gas to solid is called deposition. So now we will discuss in detail about change in temperature. So let us talk about a very small and simple activity that we can do to understand the effect of change in temperature on conversion of matter. We will take solid ice cubes in a beaker. Ice cubes in a beaker. Then we will use a spirit lamp and we will heat it from below, and we will use a thermometer to check the temperature of ice. So what we want to do is we want to convert the ice into liquid water. So how do we do that? We have to increase the temperature. When we increase the temperature, kinetic energy of particles in ice will increase. They will start moving farther away from each other, and it will convert into what is a liquid form, right? So you will do this and you will see that the ice will slowly start melting, and after some time, at one point of time, all the ice will melt in the beaker. All the ice will melt in the beaker. Now that point or that temperature at which a solid is converted into a liquid is what is called as the melting point. Melting point. What is melting? Melting is nothing but solid is converted into liquid. So we can use the word melting. So conversion of solid to liquid is called as melting. Melting is in common terms, in general terms. Scientifically, we use what is called as fusion. Melting or fusion. Nothing is nothing but conversion of solid into liquid is called as fusion. The complete conversion will take place at a particular temperature, at a particular point. Till then, some amount of ice is still left. The point at which all the ice is converted, the temperature at which all the ice is converted into liquid is what is called as your melting point. It's called as melting point. So now one important point to observe here is, although we are not doing the practical demonstration over here, what we observe during conversion of matter, during the time when the ice starts to melt and the time when the ice completely melts, there is particular duration, right? Now during this whole entire duration, if you observe the temperature in the thermometer does not increase at all, it does not change. Surprising, right? Because we know that we are heating the beaker from the bottom, from below. So when heat increases, we know that the temperature reading in the thermometer has to increase automatically. But that is not so. The temperature in the thermometer remains exactly the same. It does not increase during the whole process of conversion of ice into water. The question is why? Why does the temperature not change in the thermometer? Because all the heat that we supply with the help of the spirit lamp, the fire, the heat, all this heat is used to break the force of attraction between the particles. We know that ice is a solid. In a solid, particles are held very close to each other. Now, unless you can separate them, we cannot make it a liquid. So, all the heat that we are supplying here is used up. It is used up to break the force of attraction, and that is the reason why temperature is not increasing in the thermometer. This heat, in a way, it is getting hidden. We are supplying heat, but it is not showing as a change in temperature. Why? Because it is hidden. This hidden heat is also called as latent heat. Latent heat. How will you define latent heat? It is the heat energy required to break the force of attraction between particles. As simple as that. So till then it will not completely convert into water. When all the particles are completely separated, their attractive forces are broken down, then at that particular point all solid is converted into liquid. That point or that temperature is called as melting point, or the minimum temperature at which a solid is converted into liquid is called as melting point. Okay, so that is our melting. Next, we continue to provide heat from below. What happens? After some time, you will see small bubbles appearing from the bottom, and another few minutes later the entire vessel is bubbling, and at one point of time what will happen, we will see that vapors coming out. So here also the same phenomenon is going on. The heat that is supplied is now used up to break the force of attraction between liquid water. Water is there, so all the heat is used up to break the attractive force between water. At one point of time, all the attractive forces are broken. Particles are now not held by each other, so their kinetic energy will increase. When the kinetic energy increases, particles start moving out as vapors. That is what is called as conversion of liquid into gas, is called as vaporization. Vaporization. The temperature at which liquid water starts to boil is called as boiling point. Boiling point. The exact temperature at which liquid is converted into gas, the liquid starts to boil, is called as boiling point, right? So that is about our interconversion of matter. So now we have to discuss two more things here. One, can we convert a liquid into a solid? Liquid into solid, yes, of course we know. If we keep bottle of water inside a freezer, it will become, and that is what is called as freezing. Converting a liquid into a solid is called as freezing. The last conversion is converting a solid directly into gas. Converting a solid directly into a gas without the intermediate liquid form is called as sublimation. Sublimation. For example for sublimation, very simple. Your camphor, karpur that we use at our puja homes. So we have your camphor, we light it, and camphor is solid. When we light it, what you can see? Directly you can see it is vaporizing, gas is coming out. So what is that? Solid is converted into gas directly without any liquid form. It's called as sublimation. Another example for sublimation is your naphthalene balls. At our homes, inside our almiras and Godrej, we keep small white colored balls, right? That is our naphthalene. And after some time, you observe that the naphthalene ball, it was a solid white color ball, it has vanished completely, and you don't see any liquid at the place where you have kept the ball. Why? Because naphthalene undergoes sublimation directly from solid to gas. For that matter, even our incense stick, agarbatti, is also an example for sublimation. We burn the incense stick, directly from solid we get our gas, the nice perfumed gas we get. Conversion of solid into gas. Now, very important point to once again consider here is, in all these cases, converting a solid to liquid, liquid to gas, or any other ways, the only thing that we have done is change the temperature and change the pressure. Either we have increased the temperature or we have decreased the temperature. Either we have increased the pressure or we have decreased the pressure. So thus, by changing the temperature as well as by changing the pressure, we can alter the arrangement of particles in matter, thereby converting them into solid into liquid, liquid into gas, or any other Also, we learned about some interesting terminologies. One is fusion, conversion of solid into liquid at a temperature called as melting point. Converting a liquid into gas is called as vaporization. This takes place at a temperature called as boiling point. In both these cases, we come across a phenomenon called as latent heat. During melting as well as during boiling, we see what is called as latent heat. What is latent heat? It is the hidden heat that is used to break the force of attraction. Therefore, this heat will not be shown in as a change in the thermometer reading. Hidden heat or latent heat. And conversion of gas into liquid called as condensation. Liquid into solid is called freezing. Conversion of gas into solid is called as deposition. Gas into solid is called deposition. For example, dry ice. Converting carbon dioxide gas into dry ice solid is an example for deposition. And converting a solid into gas directly without the liquid form is called as sublimation. So that is our discussion for this particular session. Thank you.